Continuing on in section 8.5 here, with example 4, we're going to apply factoring trinomials. So here the area of a rectangle is given by the trinomial x squared minus 2x minus 35. What are the possible dimensions of the rectangle? So remember that when we find the area of a rectangle, we take our length times our width. So here, we're multiplying two things together, and because it's x squared, I know these are going to be two binomials. In order to get to x squared, I could take x times x. To get to a negative 35, I'm going to multiply to 35, and because it's negative, here I'm going to subtract to 2, my middle number. And I know 2 is negative, but we're going to account for that when we put in our signs. So here, since I subtract, I find the difference. I'm going to have different signs. So that's setting up my framework here. Now, we have to find the values that work for this. So 35 is 1 times 35, but that does not subtract to 2. We can try 2, that doesn't work. 3 doesn't go into 35 evenly, 4 doesn't, but 5 does. So 5 times 7. So our only options here are 1 and 35 or 5 and 7. And when I subtract bigger minus smaller here, I do get 2. So these are the values I want. Now I look back at my trinomial, and the sign in the middle tells me that's going to have to go with my bigger number, because we always take the absolute values and subtract them, bigger minus smaller, and then give the sign of the bigger number. So in order for 2 to be negative, it means 7 had to have been negative. So we're going to plug the 7 in with our x minus, and the 5 in with our x plus. And these are going to be my dimensions. So my dimensions could be x minus 7 and x plus 5. This is my length. This is my width based off the rectangle I drew, but it wouldn't have to be that way. And we know that the longer side would be this one, because when we add a number to x, that's going to be bigger than if I subtract a number. Not super important that we know which one's which, because again, it depends on how you draw your rectangle, but it is important to know that what we're asking here are the dimensions. And to find dimensions, we take length times width. And the two things here that we can take together multiplied to get to this trinomial are x minus 7 and x plus 5. And we can FOIL those back to double check. Firsts, outsides, insides, and lasts, combine our like terms, and it gets me back to our original polynomial. So here are our solutions, x minus 7 and x plus 5. Now, feel free to pause here and give this a try if you'd like. A rectangle's area is x squared minus x minus 72. What are the possible dimensions of the rectangle? Again, since we're talking dimensions of a rectangle, we're looking length times width. So we're looking for two things multiplied together. So we're going to write this as two things multiplied together. To get to x squared, I can take x times x. To multiply to 72, but subtract to 1, remember our coefficient is a 1 if there isn't one listed, it means I need different signs. I found the difference by subtracting, so I have different signs. It doesn't matter what order we put those in, guys, as long as the numbers we put with them are correct. So the negative number has to go with the negative sign, the positive number with the positive sign. I also can tell here that my bigger number is going to be negative because my sign in the middle is negative. Now, to multiply to 72, we have some options. We have 1 and 72. That doesn't subtract to 1. We have 2 and 36. That doesn't subtract to 1. We have 3 and 24. Doesn't subtract to 1. We have 4 and 18. Doesn't subtract to 1. 5 doesn't work. 6 and 12 doesn't subtract to 1. 7 doesn't work. We have 8 and 9, which do subtract to 1. Those are the values we're looking for. And remember, we always take bigger minus smaller and give the sign of the bigger number. So in order for it to be negative 1, that means 9, since it's bigger, would have had to have been negative. So negative 9, positive 8. So here, my dimensions would be x plus 8 and x minus 9. These are the things that we could multiply together again to get back to x squared minus x minus 72. In example 5 here, we're going to factor a trinomial. Same idea here, but the difference is that we have two variables. So when I set up my framework here, we're still going to set up our variables first. To multiply to x squared, I can take x times x. Now here we need to multiply to the entire 55y squared. So I'm going to multiply to 55. And y squared I get by taking y times y. So I can put those in my framework right away. The same way that I can with my x's, I can do that with my y's. But since my y's are in my last term, they go in my last term in my binomials. So again, we're going to multiply to 55. It's like my y's don't even exist anymore now. Just like we never worried about our x's once we put those in there. Multiply to 55, subtract 2, 6. Our options for 55 are 1 and 55. That doesn't work. That subtracts to 54. 2 doesn't work. 3 doesn't work. 4 doesn't work. 5 and 11, which subtracts to 6. So because we subtracted here, we found the difference, so our signs are going to be different. And we always give the sign in the middle to our bigger number, which here is 11. So since the middle term is positive, 11 is going to be positive, and 5 will be negative. So our factored form here is x minus 5y and x plus 11y. And again, if we FOILed that back out, firsts, outsides, insides, and lasts, and combine our like terms, we get right back to where we started. Here we're going to factor m squared plus 6mn minus 27n squared. So again, our first step is to set up our framework. M squared is m times m. Now in our last term, we're going to multiply to 27 n squared. But the only way we can multiply to n squared is by taking an n times an n in order to get 1 in the middle. Just like how my m squared is m times m, and that gives me just a single degree 1 m in my middle term, same thing with my n's. So 1 has to go in each binomial in order for our outsides and insides to both have just a degree 1 n. We're also going to subtract or find the difference to 6. Our options for 27 are 1 and 27. 2 doesn't go into 27 evenly, but 3 does. 4 doesn't, 5 doesn't, 6 doesn't, 7 doesn't, 8 doesn't, and then we're back to 9. So these are our only options. Subtracting to 6, here we get 26, not what we're looking for. Here we get 6. So again, because we found the difference here, my signs have to be different. We always give the sign in the middle to our bigger number. So the plus gets my 9, the minus gets my 3. And here's my factored form. Again, if we wanted to check these, we could FOIL them back. M squared plus 9mn minus 3mn minus 27n squared. When I combine my like terms, I get m squared plus 6mn minus 27n squared, which is what we started with. Real quick recap here for section 8.5. Some trinomials of the form x squared plus bx plus c can be factored into equivalent forms that are the product of two binomials. The signs and factors of the coefficients of the trinomial indicate how the trinomial can be factored. And that's all I have for section 8.5.